Hello again from Annie Hall. Welcome everyone that is here on site. Our next speaker is Diana Oreski, a professor at the University of Zagreb, Faculty of Organization and Informatics. She is joining us from Croatia, and she will present her amazing talk covering the effects of dataset characteristics on the performance of future selection techniques. So thank you and enjoy your next speech. Thank you.
Hello, greetings to everyone. Thank you very much for your kind introduction. My name is Diana Oreski and I come from university, largest Croatian university, University of Zagreb, where I work as associate professor. And here I will talk about one of the research I'm currently doing. And this talk is entitled Effects of Dataset Characteristics Performance of the Feature Selection Techniques. First of all, just in a minute, I will give a brief context of this research, which is part of the bigger project, which is funded by Croatian Science Foundation. And the title of the project is SIMON, Intelligent System for Automatic Selection of Machine Learning Algorithms in Social Sciences. And the aim of the project is to develop a recommender system which would recommend appropriate machine learning algorithm for data analysis. The main hypothesis of the project is that different domains, different industries have data sets of different characteristics. What we want to do here is to identify characteristics of data sets in social sciences. Our focus is on the domain of education and business, and we want to find relationship between characteristics of the datasets and performances of machine learning algorithms on such datasets. In this research, in this talk today, I will show one small part of the research where we have conducted analysis on 128 datasets. And we have evaluated a few approaches to feature selection. So in the whole project, during the 5 years, we will evaluate much more machine learning algorithms for regression, for classification, and also the big number of datasets will be included in our research. The talk is structured under one of the standards for data analysis, CRISP-DM standard, or cross-industry standard for data mining, which consists of 6 steps, which you can see here. Those are domain understanding, data preparation, modeling, evaluation, and deployment. And I will fit the tasks that we have performed in the project under these 6 steps. So, in the first step, in the domain understanding, we have performed literature review. And as all of you know, there is a huge number of machine learning algorithms which are developed so far in different and have been used in different spectrum of domains. Those algorithms have crucial power for data analysis, for extracting knowledge from datasets. However, application of such algorithms is complex, is time-consuming and iterative, and there is a need in the literature to do the automatization of the selection of appropriate algorithm for the given dataset. So the main question here is which algorithm is best to be used in a specific situation on a dataset of specific characteristics. According to no free lunch theory, there is no technique which is the best for all the datasets, and meta learning field is developed in order to learn from previous experience. So meta learning is in the focus of this project. There are several definitions of meta learning. Here you can find one of the definitions. It is process of learning from previous experience, which is gained during applying different machine learning algorithms on different kinds of data. Several approaches to meta-learning have been developed so far, and here you can see one of the taxonomy of meta-learning techniques. They are categorized into 3 groups, and those are learning from model evaluation, learning from task properties, and learning from prior models. In this talk, the focus is on the second approach, which is based on so-called meta features and developing of meta models based on those on those meta features. What are characteristics of this approach to meta-learning? So here, meta-learning techniques have been based on learning from task properties, and we are using meta features as a basis for the characterization of the particular data set. The idea is that each task is characterized by a feature of a vector of n or k vectors, and information from the prior task can be transferred to a new task based on the similarity. So this is the main idea of this group of meta-learning techniques. As I said, the hypothesis is that the selection of best set of meta features is highly dependent of the industry and domain from which data set come from. So the basis here is to identify those characteristics, and we are using meta features as a basis for dataset characterization. Here you can see one of the characterizations of meta features, and according to this grouping, there are 6 approaches to meta features. Those are simple meta features, statistical meta features, information theoretic meta features, model-based, landmarking, and clustering meta features. I will just give a brief overview in one sentence of each of the groups, so you so you see which kind of meta feature are part of each of the groups. So first one are simple meta features or general. As their name suggests, those are meta features which tell us what is the dimensionality of the data set, how many instances are in the data set, how many numerical attributes are, how many categorical, what is the ratio of categorical to numerical attributes, number of classes, number of missing values, and so on. So simple measures. Then we have statistical measures, which are based on simple statistical analysis. For instance, here one of the measures here is correlation, covariance, max, mean, median, so descriptive statistics, number of outliers, range, and so on. The third group are information theoretic meta features, and here those measures are based on entropy. As you can see here in the first column, those meta features are, for instance, attribute entropy, class entropy, joint entropy, mutual information. The following group are model-based meta features, and here we have to develop some kind of a model based on some of the machine learning algorithms, and based on that model we are deriving meta features. So for instance, if we are applying decision tree algorithm, then we have these meta features, number of leaves, number of branches, number of nodes, and so on. And we have landmarking meta features. They are rarely used, as also clustering and distance-based meta features, which are based on the clustering algorithms. So, as I said, previous research suggests that meta features have high impact on the performance of the machine learning algorithms, and we are trying to identify what are the patterns in machine learning algorithm performances according to meta features. So in the first phase, in the phase of domain understanding, we have performed literature review with the aim to identify which of the meta features have been used so far, and that literature review served as the basis for defining meta features which were applied and we will be applied in the project. In the next phase, data understanding, we have performed several activities. The main activity here is to acquire datasets. So in this first phase of the project, we have used only datasets for public repositories. So as I said, we were in this research, 128 datasets was part of the analysis, and there are here you can see the sources of those datasets. We had 32 datasets from UCLA Machine Learning Repository. Then we had 64 datasets from StatLib, 22 datasets from Sociology Data Server, and 10 datasets from Arizona State University repository. So these 128 datasets were basis for our comparative analysis. Then, in the next phase, we have performed this point 2 from the experimental design which was set up at the beginning. So we perform feature selection by applying 5 feature selection techniques, and then for each of the feature selection, we have performed classification by using 3 different machine learning algorithms. Of course, at the end, we have evaluated the results, and some guidelines were formed based on those results. We have used only a sample of the meta features, which I introduced earlier. So here are meta features which were included in this pilot research. Those are dimensionality of the datasets, number of instances, number of classes, data sparsity ratio, correlation, multivariate normality, homogeneity of class covariances, intrinsic dimensionality, and feature noise. As you can see, those characteristics are numerical continuous attributes. So in this part of data preparation, we have performed categorizations. So we want to create only 2 categories for each of the data characteristic. So that is the reason why we had 128 attributes, because we want to be sure that we have all possible combinations of those characteristics included in the data sets that we are analyzing. So for number of features, we have 2 categories, small and large, number of samples, small and large, feature noise, small and large, and so on. Okay, and here is an example for one of the features, feature noise, how categorization of the feature was applied. In the next step, in the phase of the modeling, as I said, we have performed 5 feature selection techniques and 3 machine learning algorithms to detect patterns in their performances. Feature selection techniques which were included in the research are here. Of course, in the following phases, there will be much more approaches to feature selection. These 5 techniques were selected based on the literature review because they have been used extensively so far in the research. So those techniques are information gain, gain ratio, relief, linear forward selection, and voting feature selection. I will just give a brief overview of each of the technique in a sentence or 2. So first approach is relief. it works in a way that estimates the quality of features according to how well their value distinguish between instances that are near each other. Then relief randomly samples an instance from the data and locates its nearest neighbor from the same class and its opposite class. So the values of the attributes of the nearest neighbors are compared to the sampled instance and used to update relevant scores for each attribute. The idea behind this algorithm is that useful attribute should differentiate between instances from different classes, but have the same value for instances for the same class. Then we have information gain, which is one of the most commonly used feature evaluation techniques. It measures the amount of information in bits about the class prediction if the only information available is the presence of feature and corresponding class distribution. Next is gain ratio, which is actually based on the information gain measure. Information gain measure has preferences to the features having a large number of values, and the gain ratio is trying to overcome this disadvantage. Then we have used linear forward selection, which refers to a search that begins with an empty set of features and progressively incorporates features into larger and larger data sets. This approach is robust against overfitting, and it is one of the biggest advantages of this approach. And at the end, voting feature selection technique is applied. It uses weighted average of all feature selection techniques, those 4 mentioned earlier, and based on that selects features. I said that we are using here meta features, and based on that, we are developing meta models which would suggest appropriate techniques. Here, meta models were used by applying supervised machine learning algorithms. There are also different approaches to developing meta models. Some of the approaches are to use correlation or to use multi-criteria decision-making methods. We will also evaluate that approaches and compare it to these approaches here. But as I said, here we have used supervised machine learning algorithms, and this categorization was used from Michi and Spielberg, which divides machine learning algorithms into 3 groups: statistical, neural, and machine learning algorithms. And from each group, we have used one algorithm. Discriminant analysis from statistical algorithms, then neural networks from the second group, and decision tree from the group of machine learning algorithms. Here is a brief overview of each of the applied machine learning algorithms. So discriminant analysis have some kind of assumptions which needs to be satisfied in order to perform modeling. So we have to find the data sets that satisfy all those assumptions. Of course, this is a parametric approach to the modeling. Opposite to that, neural networks approach and decision tree algorithm are non-parametric approaches, and they do not have that kind of assumptions. Neural networks are one of the most widely used learning algorithms, and of course here are applied artificial neural networks, and their idea is based on the biological neural network. When we have performed optimization of the parameters, one of the most important tasks here were to define number of layers at the network, and then to define number of hidden nodes in the hidden layer of the network, because if we set up a big number, then overfitting can be occurred. So there is a need to balance between good performance of the model, measure in accuracy or in the reliability on the one hand, and on the other hand, we are trying that, of course, this model can be interpretable. And at the end, decision tree was used as a third approach to machine learning. There are several advantages of using decision tree. One of the advantages is interpretability of the model, which is presented, as you will see, in the form of tree and can be translated into the rules, which can be good basis for the recommendations and input into the recommender system, which is developed at the end. Okay, now I will present the results. Josip now is here, and I will be much smarter in the. I have a few mistakes here, which I know now after your talk. Okay, so here are the average values for each of the 5 feature selection techniques, and the results are accuracy of the 3 models that we have performed, so neural networks, discriminant analysis, and decision tree. So according to these results, as I said, average results of the all datasets, this result would suggest that relief has the highest average overall accuracy, and when using in combination with decision tree, right? Now we will take a look at the results for each of the models specifically. So for the neural network model, discriminant analysis, and decision tree model. We have used, as I said, decision trees in the evaluating the results, because as you can see, model results are presented in the form of tree, or tree as upside down, where we have meta features as a nodes in the tree, and here at the end is suggested feature selection technique. So basically, in each branch, we can see one rule. For instance, first branch suggests that if we have a data set which has a large feature noise and small data sparsity, then relief is suggested to apply it in feature selection if we are performing modeling afterwards by applying neural networks. This tree is then converted into the rules, so rules in the form if-then, where we can see inputs, so which meta features and values of those meta features, and which technique is best to be used for the certain situation. Also, in the last phase of the research evaluation, we have performed sensitivity analysis in order to see which of those meta features which were employed actually have the most significant impact on the results, or which of these meta features are the best predictors for feature selection technique recommendation. And in this case, in the case of neural network modeling, data sparsity and correlation and feature noise are among 3 best predictors. So those were results for neural network models. Then we had a discriminant analysis, which yielded the most simple tree, indicating those 3 features are important: feature noise, number of instances, and correlation. And those are 4 very simple rules which were extracted from the tree. And also, as a model of decision tree suggested, there were only 3 important meta features for selection of feature selection technique in the case of discriminant analysis modeling. And as third part, we have employed decision tree. And in this case, this model was gained as a result. Of course, decision tree model is extracted into the rules. I want to go now into details of which feature selection technique is best to be used based on dataset characteristics, but you see the idea behind this. And this is results of the sensitivity analysis performed on the decision tree models. And we can see here that the most significant predictor was number of features. So we can see that there are differences between importance of meta features. We're using different machine learning approaches in the modeling phase. And we have 2 more steps, evaluation and deployment. During the evaluation, we have used tenfold cross-validation. I believe most of you are familiar with the approach, so I won't now explain that. And at the end, we have used Friedman test to test the significance of the differences between the results. Friedman test is non-parametric approach to testing the differences because we did have some data sets which did not satisfy assumptions that parametric tests have. These results, and by the results I mean the rules that we saw, will be integrated into the intelligent system, which would be end result hopefully for 3 years. As I said, here we have used supervised learning algorithms in developing meta models. In the following phases, we will also use these 2 approaches, correlation, ranking, and some of the multi-criteria decision-making methods. And we will compare which of these meta models have the best parameters. And of course, the meta model which will have the highest accuracy will be integrated in the intelligent system at the end. This is the framework of that system, and it will be conducted, of course, in the phase of deployment. So here we saw results of analysis of data sets of 128. Our repository is growing, so there will be much more data sets included. For each of the data sets, meta features will be calculated, not only 7 meta features which were presented here, but much more which are identified in the literature review. And on each of the data sets, we will perform machine learning algorithms for the modeling. And then those input meta features and output meta features, and by the output I mean the results and the accuracy and reliability of these algorithms, will serve as a metadata input in meta learning, and based on that we will develop more models for algorithm selection. So in the future research, as I said, we will include more data sets, more meta features to characterize those data sets, more feature selection techniques for data preparation, and at the end, more machine learning algorithms for classification and regression tasks. And those results will be basis for development of intelligent system, which would hopefully help to automate the process of selection of appropriate machine learning algorithm of a given data set. And that's all. Thank you very much for your attention.
Thank you, Diana, very much. Do we have a question from audience? So I guess you're hungry. Waiting for that. Okay, so then thank you for your wonderful research and talk. I'm really happy that you joined us today here. And I want to invite everyone to join us for lunch. It will last until 2 p.m. And after that, in this hall, we will have the Ulm Theobald at 3 p.m. or at 3 o'clock starts the next speech here. And once again,